Tonight, we embark on a journey through the cosmos to explore one of the most profound thought experiments in astrophysics. What would happen if Earth simply vanished from existence? Not destroyed by some cosmic catastrophe, not consumed by fire or ice, but simply removed from the fabric of space and time as if it had never been there at all. This question touches the very heart of how our universe operates, how gravity weaves the cosmic dance between celestial bodies, and how even the smallest changes can ripple outward through space and time in ways both subtle and profound. As we drift through this exploration together, we'll discover that the answer reveals something beautiful about the delicate balance that holds our solar system together, and something even more beautiful about just how precious our pale blue dot truly is. Picture this moment, if you will. In the vastness of space, 93 million miles from our Sun, Earth orbits in its familiar elliptical path. The planet spins gently on its axis, carrying with it the Moon, our faithful companion that has watched over us for billions of years. Everything appears normal, peaceful, eternal. And then, in an instant that defies the very laws of physics as we understand them, Earth simply ceases to exist. The first and most immediate consequence of this impossible event would unfold in the realm of our nearest cosmic neighbour. The Moon, which has been locked in gravitational embrace with Earth for over 4 billion years, would suddenly find itself freed from the invisible tether that has guided its monthly dance around our planet. At the precise moment of Earth's disappearance, the Moon would be travelling at approximately 1 kilometre per second in its orbital path. This velocity, combined with the laws of physics that govern motion in the vacuum of space, would determine our satellite's immediate fate. Without Earth's gravitational pull to curve its trajectory into that familiar circular path we see each night, the Moon would continue moving in whatever direction it happened to be travelling at that exact moment. Newton's first law of motion tells us that an object in motion stays in motion unless acted upon by an outside force. With Earth's gravitational force suddenly absent, the Moon would sail off into space along a straight line, tangent to its former orbital path. But the Moon would not simply drift aimlessly through the void. Our solar system is dominated by a much larger gravitational influence, one that has shaped the paths of planets, moons, asteroids and comets for billions of years. The Sun, containing over 99% of all the mass in our solar system, would immediately begin to assert its gravitational control over the newly liberated Moon. The Moon's journey into solar orbit would be unlike anything in our solar system's current configuration. Depending on exactly where in its monthly orbit around Earth the Moon happened to be when our planet vanished, it would enter a solar orbit with characteristics entirely different from Earth's familiar yearly path around the Sun. The Moon's orbit around Earth is inclined about 5 degrees relative to the plane of Earth's orbit around the Sun. This means that the Moon's new solar orbit would likely have a different inclination, a different period, and a different eccentricity than the orbit Earth once followed. Initially, this new orbit might not seem dramatically different from Earth's path. The Moon's orbital velocity around Earth is roughly comparable to Earth's orbital velocity around the Sun, both hovering around 30 kilometers per second when we consider the combined motion. This curious coincidence means that the Moon might settle into a solar orbit that bears some resemblance to Earth's former path, at least for a while. However, the solar system is not a simple two-body system of just the Sun and one orbiting object. The gravitational influences of other planets, particularly the massive Jupiter and the nearby inner planets Mars and Venus, would begin to exert their subtle but persistent effects on the Moon's trajectory. These gravitational perturbations, tiny nudges that accumulate over time, could gradually alter the Moon's orbit in unpredictable ways. Over the span of centuries, these small changes could compound into dramatic alterations. Computer models suggest that the Moon's new orbit could evolve to cross the paths of Mars or Venus, potentially leading to a gravitational encounter, or even a collision with one of these worlds. The Moon, now a rogue satellite wandering through the inner solar system, would become subject to the complex gravitational choreography that has shaped planetary evolution for billions of years. While the Moon begins its solitary journey around the Sun, the broader solar system would initially appear largely unchanged. The inner planets, Mercury, Venus, and Mars, would continue their ancient orbital paths around the Sun with barely perceptible alterations. Earth's mass, while significant to us, represents only a tiny fraction of the solar system's total mass. The gravitational influence that Earth exerts on distant planets is correspondingly small, measured in subtle perturbations that accumulate over vast periods of time. Mercury, racing around the Sun in its tight 88-day orbit, would experience virtually no immediate change in its trajectory. The innermost planet's proximity to the Sun's overwhelming gravitational field means that Earth's distant influence was already negligible. Venus, our nearest planetary neighbour, might experience slightly different gravitational nudges from the asteroid belt and outer planets, but these changes would be so minute as to be nearly immeasurable over human timescales. Mars presents a more interesting case. The red planet's orbit occasionally brings it relatively close to Earth's former position, and the gravitational interactions between our two worlds have played a subtle role in maintaining the stability of both orbits over geological time. Without Earth's gravitational influence, Mars might experience slight changes in its orbital eccentricity and inclination over millions of years, though these alterations would unfold so gradually as to be imperceptible to any hypothetical Martian observers. The outer planets, Jupiter, Saturn, Uranus, and Neptune, would be even less affected by Earth's sudden absence. These massive worlds, particularly Jupiter, with its enormous gravitational influence, have always been the primary shapers of outer solar system dynamics. Earth's disappearance would remove one small source of gravitational perturbation from their complex orbital mechanics, but the effect would be far too small to meaningfully alter their paths around the Sun. Perhaps the most fascinating immediate consequence of Earth's vanishing would occur not in the realm of orbital mechanics, but in the fundamental fabric of space and time itself. According to Einstein's theory of general relativity, mass and energy curve the geometry of space-time, creating what we perceive as gravitational fields. Earth's mass creates a depression in this cosmic fabric, a gravitational well that has influenced the motion of nearby objects for billions of years. The sudden removal of Earth's mass would create a violent disturbance in space-time itself, propagating outward from Earth's former location at the speed of light. These ripples in the fabric of reality, known as gravitational waves, would carry the news of Earth's disappearance to every corner of the universe. Unlike light or radio waves, gravitational waves can pass through matter virtually unimpeded, stretching and compressing space itself as they travel. The gravitational waves generated by Earth's instant disappearance would be unlike anything ever detected by our current gravitational wave observatories. These facilities, such as LIGO and Virgo, are designed to detect the incredibly faint ripples produced by colliding black holes and neutron stars billions of light years away. The sudden vanishing of Earth's entire mass would create gravitational waves potentially millions of times stronger than anything we've ever observed, though still incredibly weak by everyday standards. As these waves pass through the solar system, they would cause tiny, rhythmic changes in the distances between planets, moons, and asteroids. The effect would be extraordinarily small, perhaps changing the distance between Earth's former location and Mars by less than the width of a single atom. Yet this minuscule distortion would represent a permanent alteration in the structure of space-time itself, a cosmic memory of Earth's existence that would propagate outward through the universe for eternity. The asteroid belt, that vast collection of rocky debris orbiting between Mars and Jupiter, would experience subtle but important changes in the wake of Earth's disappearance. Currently, Earth's gravitational influence helps to deflect some asteroids and contributes to the complex dance of gravitational interactions that shapes asteroid trajectories. Without this influence, The long-term evolution of asteroid orbits would follow slightly different paths. Some asteroids that currently follow stable orbits might gradually drift into different regions of the belt over millions of years. Others that were previously nudged away from Earth-crossing trajectories by our planet's gravity might eventually find their way into orbits that would have brought them dangerously close to our world, had it still existed. These changes would unfold over geological timescales, invisible to any human observer, yet significant in the grand choreography of solar system evolution. The Sun itself would barely register Earth's absence in any measurable way. Our star contains over 333,000 times the mass of Earth, making our planet's gravitational contribution to solar dynamics utterly negligible. The Sun would continue its nuclear fusion processes, converting hydrogen to helium in its core and radiating energy into space, completely unaware that one of its planetary children had vanished without a trace. However, the energy implications of Earth's disappearance raise profound questions about the fundamental nature of reality itself. Einstein's famous equation, E equals mc squared, tells us that mass and energy are equivalent. Earth's mass, approximately 6 trillion kilograms, corresponds to an energy equivalent roughly equal to the total energy output of the Sun for about 1.5 million years. The laws of physics, specifically the conservation of energy, tell us that this enormous amount of energy cannot simply disappear. It must go somewhere, transform into something else, or reveal that our understanding of physical laws remains incomplete. In our thought experiment, we might imagine this energy converting entirely into gravitational waves, flooding the universe with ripples in space-time that would eventually reach every galaxy, every star, every planet in the observable cosmos. This raises a beautiful paradox at the heart of our exploration. The very laws of physics that govern the universe seem to forbid Earth's sudden disappearance, suggesting that our planet's existence is woven so fundamentally into the fabric of reality that its removal would require a complete rewriting of the cosmic rulebook. In a universe governed by conservation laws, nothing truly vanishes. Everything transforms, everything continues, everything matters in the grand calculation of existence. As we drift deeper into this cosmic meditation, we begin to understand that Earth's hypothetical disappearance would send subtle ripples through space and time, affecting everything from the Moon's trajectory to the fundamental structure of space-time itself. Yet these changes, profound as they might be on astronomical scales, would barely register in the vast indifference of the cosmos. The universe, in its infinite majesty, would continue its ancient dance of expansion, star formation, and galactic evolution, largely unaware that a small blue world had quietly slipped away from a modest yellow star in an unremarkable corner of an ordinary galaxy. Yet in this grand cosmic theatre, there are other players whose stories would unfold with quiet drama in the wake of Earth's absence. The space between worlds, far from being empty, pulses with invisible forces and streams of charged particles that have flowed through our solar system since its birth. The solar wind, that constant river of charged particles streaming outward from our Sun, would continue its journey unimpeded, no longer encountering the protective magnetic bubble that Earth's magnetic field once created. Our planet's magnetosphere, that invisible shield generated by the churning of molten iron in Earth's core, has for billions of years deflected harmful solar radiation, creating the aurora that dance across polar skies and protecting the delicate chemistry of life below. With Earth gone, this magnetic fortress would vanish instantly, leaving behind only the memory of its influence recorded in the trajectories of cosmic particles that had been gently guided around our world for eons. The solar wind would flow through the space where Earth once stood, undeflected, carrying with it the story of our Sun's nuclear heart. These particles, mostly hydrogen and helium nuclei, accelerated to incredible speeds, would continue their billion-year journey toward the edge of our solar system, where they eventually merge with the interstellar medium that flows between the stars. In this realm of charged particles and magnetic fields, we find one of the most subtle yet profound changes that Earth's disappearance would bring to our cosmic neighborhood. The heliosphere, that vast bubble of solar influence that extends far beyond the orbit of Pluto, would be ever so slightly altered by the absence of Earth's magnetic field. The shape and dynamics of this boundary between our solar system and interstellar space would shift in ways so minute that they would be undetectable except to the most sensitive instruments. Yet these changes would represent a permanent alteration in how our solar system interacts with the galaxy beyond. As we drift further into our meditation on cosmic consequences, we encounter the fascinating realm of orbital resonances, those hidden mathematical relationships that have kept our solar system stable for billions of years. These resonances are like cosmic music, mathematical harmonies that arise when the orbital periods of different bodies form simple ratios. Earth has participated in this celestial symphony, its gravitational influence contributing to the delicate balance that prevents planetary orbits from drifting into chaos. The asteroid belt provides the most dramatic example of how these resonances shape our solar system. Throughout this region of space between Mars and Jupiter, there are gaps known as Kirkwood gaps, zones nearly empty of asteroids that correspond to orbital periods that would form simple ratios with Jupiter's orbit. Jupiter's immense gravitational field has swept these regions clean over millions of years, ejecting asteroids that ventured too close to these resonant relationships. Earth's gravitational influence, while much smaller than Jupiter's, has also contributed to this cosmic housekeeping. Our planet has helped nudge certain asteroids away from potentially dangerous orbits, contributing to the relative stability that has allowed complex life to flourish for hundreds of millions of years. Without Earth's gentle gravitational guidance, some asteroids might gradually drift into different orbits over geological time, though these changes would unfold so slowly that they would be imperceptible across human timescales. The dance of orbital mechanics extends beyond our immediate solar neighborhood to influence the very architecture of space around us. The Lagrange points, those special locations where the gravitational forces of two massive bodies balance perfectly, would be profoundly affected by Earth's disappearance. These points, named after the mathematician Joseph Louis Lagrange, exist in the gravitational relationship between Earth and the Sun, creating stable islands in space where smaller objects can maintain their positions with minimal energy expenditure. Currently, these Earth-Sun Lagrange points host several important spacecraft and natural objects. The James Webb Space Telescope occupies the second Lagrange point, positioned 1.5 million kilometers from Earth in the direction away from the Sun, where it can observe the cosmos with unprecedented clarity while remaining in Earth's shadow. Asteroids known as Earth Trojans inhabit the fourth and fifth Lagrange points, sharing Earth's orbit around the Sun while maintaining stable positions 60 degrees ahead of and behind our planet. With Earth's sudden absence, these Lagrange points would simply cease to exist. The James Webb Telescope and any other objects at these locations would find themselves in unstable orbits, subject to the gravitational influence of the Sun alone. They would begin to drift, their carefully maintained positions disrupted, eventually settling into new solar orbits determined by their velocities at the moment Earth vanished. This dissolution of the Earth-Sun Lagrange points represents more than just a change in spacecraft trajectories. It symbolizes the breaking of a gravitational partnership that has existed for billions of years. The severing of invisible threads that have helped weave the fabric of stability in our corner of the cosmos. The mathematical elegance of these points, where forces balance in perfect harmony, would be replaced by the simpler but less nuanced gravitational relationship between these objects and the Sun alone. As we contemplate these changes unfolding across our solar system, we begin to appreciate the interconnected nature of gravitational relationships. Every mass in our cosmic neighborhood, from the smallest asteroid to the mightiest planet, participates in an intricate web of gravitational influences that has been shaped by billions of years of celestial evolution. Earth's role in this web has been that of a middle player, neither dominant like Jupiter nor negligible like the smaller moons, but significant enough to contribute to the overall stability and character of our solar system. The removal of Earth from this web would be like removing a single thread from a vast cosmic tapestry. The overall pattern would remain largely intact, but subtle changes would propagate through the weave, creating new relationships and breaking others that have existed since the dawn of our solar system. These changes would unfold across timescales that dwarf human history, yet they represent real and permanent alterations to the cosmic order we have always known. In the realm of planetary science, Earth's disappearance would also affect our understanding of how rocky planets form and evolve. Our world serves as a crucial data point in the study of terrestrial planet formation, offering insights into the processes that shape rocky worlds throughout the universe. Earth's unique characteristics, its size, its distance from the Sun, its large moon, and its active geology have all contributed to the development of conditions suitable for life as we know it. Without Earth as a reference point, our understanding of planetary habitability would be incomplete, lacking the example of a world where life not only emerged, but flourished and evolved into countless forms of breathtaking complexity. The loss of this living laboratory would represent more than just a change in cosmic mechanics. It would remove from the universe the only known example of a planet where matter has organized itself into patterns complex enough to contemplate its own existence. The study of exoplanets, those worlds orbiting distant stars, often relies on comparisons with Earth to assess their potential habitability. Astronomers speak of planets in the Goldilocks zone, that range of distances from a star where liquid water might exist on a planet's surface, taking Earth as the model for what such a world might look like. Without Earth's example, our search for life elsewhere in the universe would lack its most important reference point. The one world we know with certainty has harbored life for billions of years. As we drift deeper into this cosmic meditation, we encounter the profound question of observation and measurement. If Earth vanished, who would be there to notice? The planets themselves have no consciousness with which to observe the change. The Sun continues its nuclear burning without awareness of the worlds that orbit it. The universe, in its vast indifference, proceeds with its expansion and evolution, regardless of the presence or absence of any single world. Yet there is something hauntingly beautiful about imagining the cosmic consequences that would unfold in the absence of any observers to witness them. The moon would begin its solitary journey around the Sun, carrying with it no memory of the blue world it once circled. The gravitational waves would ripple outward through space-time, bearing the mathematical signature of Earth's former existence to galaxies billions of light-years away, though there would be no one to decode their message or understand their significance. In this scenario, the universe would become a place of pure physics, where events unfold according to mathematical laws without consciousness to interpret their meaning or beauty. The elegant dance of orbital mechanics would continue, the slow evolution of stellar systems would proceed, and the cosmic web of dark matter and energy would expand and flow exactly as the equations of general relativity predict. But there would be no minds present to appreciate the sublime order underlying it all. This absence of observers raises profound questions about the nature of existence itself. Does an event have meaning if there is no consciousness present to witness it? Do the laws of physics continue to operate in their familiar way, even when there are no scientists to discover and describe them? These questions touch the very foundations of our understanding of reality and our place within it. Perhaps most remarkably, the universe would continue to create new possibilities for observation and consciousness to emerge. Stars would continue to form from collapsing clouds of gas and dust, and around these stars, new planetary systems would coalesce from the cosmic debris of stellar birth and death. On some of these worlds, given enough time and the right conditions, matter might once again organize itself into patterns complex enough to wonder about its own existence, to look up at the night sky and ponder the vast cosmos that surrounds it. The cycle of cosmic evolution that gave birth to Earth and all its inhabitants would continue elsewhere, in other star systems, around other suns, creating new opportunities for complexity, consciousness, and wonder to emerge from the fundamental forces that govern our universe. In this sense, Earth's disappearance would represent not an ending, but a transition, a passing of the torch of awareness from one corner of the cosmos to another. As we consider these vast timescales and cosmic possibilities, we begin to understand that Earth's hypothetical absence would be absorbed into the larger story of universal evolution with barely a ripple. Our solar system would continue its 225 million-year orbit around the center of the Milky Way galaxy, carrying its cargo of planets and moons and asteroids through the spiral arms of stars and gas clouds that define our galactic home. The Milky Way itself would continue its gravitational dance with the Andromeda Galaxy, approaching slowly over billions of years toward an eventual merger that will reshape both galaxies into something entirely new. In this cosmic waltz, the presence or absence of a single rocky planet around an ordinary yellow star would make no measurable difference to the grand choreography of galactic evolution, yet there is something profoundly moving about contemplating our planet's small but real role in this vast cosmic story. Earth has been the stage upon which the drama of life has unfolded for billions of years, the only known theatre in the universe where matter has awakened to contemplate its own existence and reach out toward the stars with instruments and imagination. The gravitational memory of Earth's existence would persist in ways both profound and subtle. Written into the very structure of space-time, like an invisible signature that speaks to the fundamental interconnectedness of all things. This cosmic memory would manifest through mechanisms that Albert Einstein could never have fully envisioned when he first described the curvature of space and time around massive objects. In the immediate aftermath of our planet's disappearance, the region of space where Earth once resided would retain a kind of gravitational echo. The space-time curvature that our world had maintained for over 4.5 billion years would not simply snap back to flatness instantaneously. Instead, this cosmic fabric would undergo a process of relaxation, settling gradually into its new configuration, like the surface of a pond, slowly returning to stillness after a stone has been removed from its depths. This relaxation would occur through the propagation of gravitational waves, those ripples in space-time that carry energy and information at the speed of light. Unlike the violent gravitational waves we detect from colliding black holes or neutron stars, these waves would be gentler, more diffuse, representing the gradual unwinding of Earth's gravitational field rather than a catastrophic collision. Yet they would be no less significant in their implications for our understanding of how the universe maintains its accounts of mass and energy. As these waves spread outward from Earth's former location, they would carry with them a precise mathematical description of our planet's mass, its rotation, and even subtle details about how that mass was distributed within Earth's interior. Any sufficiently advanced civilization with gravitational wave detectors, sensitive enough to measure these incredibly faint signals, would be able to reconstruct a detailed portrait of Earth's physical characteristics, even millions of years after our world had vanished. The speed at which this gravitational information propagates reveals something beautiful about the nature of cosmic communication. While light from Earth's former position would cease immediately upon our planet's disappearance, the gravitational waves would continue to carry news of Earth's existence outward through the universe for eternity. Stars located 10 light-years away would receive this gravitational message 10 years after Earth's disappearance. Galaxies millions of light-years distant would eventually detect these faint ripples in space-time, learning of Earth's former existence long after any electromagnetic trace of our civilization had faded into the cosmic background. This raises a fascinating possibility that touches the very heart of what it means for something to truly exist in the universe. Even after Earth has vanished completely, even after the last photons of sunlight reflected from our blue skies have travelled beyond the edge of the observable universe, the gravitational waves carrying the signature of our world's mass would continue their eternal journey through space and time. In this sense, Earth would achieve a kind of physical immortality, its existence permanently recorded in the fundamental structure of space-time itself. The implications extend beyond mere academic curiosity into the realm of cosmic archaeology. If advanced civilizations in distant galaxies possess gravitational wave detectors far more sensitive than anything we can currently imagine, they might be able to read the history of our solar system written in these space-time ripples. The formation of planets, the migration of Jupiter in the early solar system, the great bombardment that scarred the moon and shaped Earth's early evolution, all of these events would have generated gravitational waves that are still propagating outward through the universe, carrying their stories to anyone capable of listening. But let us drift our attention from these cosmic communications to consider the more immediate effects that would unfold within our own stellar neighbourhood. The space surrounding our solar system, that vast region where the sun's influence gradually gives way to the pull of other stars, would experience subtle but measurable changes in the wake of Earth's disappearance. The heliosphere, that enormous bubble of charged particles blown outward by our sun's solar wind, extends far beyond the orbit of Pluto, creating a boundary between our solar system and the interstellar medium. Earth's magnetic field has always contributed to the complex dynamics of this region, deflecting cosmic rays and channeling solar wind particles in patterns that have remained stable for geological ages. Without our planet's magnetic influence, the shape and behaviour of the heliosphere would shift in ways that might not become apparent for decades or centuries. These changes would be extraordinarily subtle, detectable only through long-term measurements of cosmic ray intensities and solar wind particle distributions. Yet they would represent real and permanent alterations to the boundary between our solar domain and the galaxy beyond. Space probes like Voyager 1 and Voyager 2, now travelling through the interstellar medium beyond the heliosphere, would detect these changes as slight variations in the cosmic ray background and magnetic field orientations they encounter. The Pioneer plaques and Voyager golden records, those messages we have sent into interstellar space carrying information about humanity and Earth, would continue their eternal journeys through the galaxy, becoming the only remaining physical artifacts of our world's existence. These spacecraft would carry their precious cargo of human knowledge and creativity outward through the Milky Way, perhaps to be discovered by other civilizations millions of years in the future, long after Earth itself had become nothing more than a fading gravitational wave signature propagating through the cosmic void. As we contemplate these vast scales of space and time, we encounter one of the most profound questions raised by Earth's hypothetical disappearance. Would the universe, in any meaningful sense, notice that our world had gone? To address this question, we must consider what it means for the universe to notice anything at all. The cosmos operates according to physical laws that are, as far as we know, entirely indifferent to the particular arrangements of matter and energy they govern. The equations of general relativity that describe the curvature of space-time around massive objects make no distinction between the mass of Earth and an equivalent amount of matter arranged in any other configuration. From the perspective of these fundamental laws, Earth's disappearance would represent nothing more than a redistribution of energy, significant only in its violation of conservation principles. Yet there is another sense in which the universe might be said to notice Earth's absence, a sense that has to do with the extraordinary improbability of our world's particular characteristics. Earth occupies a position in what astronomers call the habitable zone around our Sun, that narrow range of distances where liquid water can exist on a planetary surface. But this is only the beginning of the remarkable series of coincidences that have made our world suitable for the emergence and evolution of life Earth's size gives it just enough gravitational pull to retain a substantial atmosphere without being so massive that it becomes a gas giant like Jupiter. Our planet's rotation rate creates day and night cycles that prevent extreme temperature variations while generating the magnetic field that protects us from harmful solar radiation. The Moon's presence stabilizes Earth's axial tilt, preventing dramatic climate changes that might otherwise make complex life impossible. Perhaps most remarkably, Earth's interior remains geologically active, driving the plate tectonics that recycle carbon and maintain the chemical balance necessary for life, while generating the magnetic field that shields our atmosphere from being stripped away by the solar wind. This geological activity depends on Earth's size, its distance from the Sun, and the presence of radioactive elements in our planet's core that continue to provide heat billions of years after Earth's formation. The probability of all these factors aligning to create a world suitable for life appears to be extraordinarily small. Current estimates suggest that Earth-like planets may be exceedingly rare in the universe, perhaps occurring around only 1 in billions of stars. If this assessment is correct, then Earth's disappearance would represent the loss of something almost unimaginably precious, a cosmic treasure whose rarity approaches the unique. From this perspective, the universe might indeed notice Earth's absence, not through any conscious awareness, but through the sudden elimination of the only known location where matter has organized itself into patterns complex enough to contemplate the cosmos itself. Earth hosts the only confirmed example of life in the universe, the only place where the fundamental particles and forces of nature have combined to create beings capable of love, art, music, science, and wonder. The loss of this biological richness would represent more than just the extinction of individual species, or even the end of human civilization. It would mean the elimination of billions of years of evolutionary experimentation, the destruction of countless solutions to the challenges of survival and reproduction that life on Earth has discovered through trial and error across geological time. Each species that has ever lived on Earth represents a unique experiment in the organization of matter and energy, a particular approach to the challenge of extracting order from chaos and creating meaning from randomness. The disappearance of Earth would also eliminate the only known example of a planet where matter has developed the capacity for memory, creativity, and forward planning. Human consciousness, whatever its ultimate physical basis might be, represents an extraordinary development in the universe's capacity for self-awareness. Through human minds, the universe has become capable of observing and understanding itself, of creating art and music and literature that capture and express the beauty and mystery of existence. This capacity for consciousness and creativity extends beyond humanity to encompass the rich cognitive lives of countless other species that share our planet. The complex social behaviors of dolphins and whales, the problem-solving abilities of cephalopods, the intricate communication systems of birds, and the emerging understanding we have of plant intelligence all represent different experiments in consciousness and cognition that have emerged from Earth's biosphere. Yet as we drift deeper into this meditation on cosmic significance, we must also acknowledge the profound humility that comes from contemplating the true scale of the universe. Our Milky Way galaxy contains approximately 400 billion stars, and current estimates suggest there may be over 2 trillion galaxies in the observable universe alone. The total number of stars in the cosmos may exceed 10, followed by 24 zeros, a number so vast that it challenges human comprehension. Even if Earth-like planets are extraordinarily rare, occurring around only 1 star in a billion, the sheer scale of the universe suggests that millions or even billions of such worlds may exist. From this cosmic perspective, Earth's disappearance, tragic as it would be for us, might represent nothing more than a statistical fluctuation in the grand experiment of cosmic evolution. The universe has been conducting this experiment for nearly 14 billion years, creating and destroying countless worlds, stars, and even entire galaxies in an ongoing process of creation and dissolution that operates on scales far beyond human experience. Stellar nurseries in distant galaxies are continuously forming new planetary systems, while the gravitational collapse of dying stars creates the heavy elements necessary for rocky planets and complex chemistry. In this context, Earth's hypothetical disappearance becomes part of a much larger story about the universe's capacity for renewal and transformation. The carbon atoms that make up our bodies were forged in the nuclear furnaces of ancient stars that lived and died billions of years ago, of the calcium in our bones, the iron in our blood, and the oxygen we breathe, all originated in stellar explosions that scattered these elements across the cosmos, eventually incorporating them into the molecular clouds that would give birth to our sun and solar system. When our sun eventually exhausts its nuclear fuel and expands into a red giant star some 5 billion years from now, it will likely engulf and vaporize Earth, returning our planet's atoms to the interstellar medium. These atoms will then become available for incorporation into future generations of stars and planets, perhaps giving rise to new worlds where matter might once again organize itself into patterns capable of consciousness and wonder. This cosmic recycling process suggests that Earth's disappearance, whether sudden or gradual, represents not an end, but a transformation, a changing of the guard in the universe's ongoing exploration of complexity and consciousness. The atoms that currently constitute our world and everything on it will continue to exist, participating in new arrangements and configurations as the cosmos continues its evolution toward whatever strange and wonderful futures await. The timescales involved in these cosmic processes dwarf human history and even the entire span of life on Earth. Our species has existed for only about 300,000 years, a mere eye blink compared to Earth's 4.5 billion year history. Complex life has flourished on our planet for roughly 600 million years, while simple single-celled organisms have been present for over 3.5 billion years. Yet even these vast biological timescales pale in comparison to the future evolution of the universe. Current cosmological models suggest that star formation will continue for perhaps another trillion years, gradually slowing as the universe expands and the raw materials for stellar birth become increasingly dispersed. During this unimaginably long period, countless new planetary systems will form, and some fraction of these will likely develop conditions suitable for the emergence of life and consciousness. If we could somehow observe the universe across these cosmic timescales, Earth's disappearance might appear as nothing more than a brief flickering in the grand tapestry of cosmic evolution. Yet for us, in this particular moment of space and time, Earth represents everything we have ever known or can hope to know about existence itself. Our entire understanding of physics, chemistry, biology, and consciousness derives from observations and experiments conducted on this single world orbiting an ordinary star in an unremarkable region of a typical spiral galaxy. This paradox between cosmic insignificance and absolute importance lies at the heart of the human condition. We are simultaneously the products of cosmic forces that operate on scales beyond imagination, and the only known observers capable of contemplating these very forces. We are made of star stuff, as Carl Sagan so eloquently expressed, yet we are star stuff that has become aware of its own stellar origins. The contemplation of Earth's hypothetical disappearance thus becomes more than just an exercise in astrophysics and orbital mechanics. It becomes a meditation on the nature of existence itself, on the extraordinary improbability of consciousness emerging from the fundamental particles and forces that govern the universe, and on the profound responsibility that comes with being the cosmos's only known observers. If Earth were to vanish tomorrow, the universe would continue its ancient dance of expansion and evolution with barely a pause. New stars would be born, new planets would form, and new opportunities for complexity and consciousness would emerge across the vast reaches of space and time. The physical laws that govern the cosmos would remain unchanged, and the mathematical relationships that describe orbital mechanics, stellar evolution, and galactic dynamics would continue to operate exactly as they always have. Yet something irreplaceable would be lost, something that might not emerge again for billions of years, if ever. The particular combination of circumstances that gave rise to Earth's biosphere, to the emergence of consciousness, and to the development of science, art, and philosophy represents a cosmic lottery win of almost unimaginable proportions. The loss of this achievement would impoverish the universe in ways that transcend mere physics and touch the very meaning of existence itself. In the end, perhaps the most profound consequence of Earth's disappearance would be the silence that would fall across our corner of the cosmos. No longer would radio telescopes scan the skies for signs of extraterrestrial intelligence. No longer would space probes venture forth to explore the moons of Jupiter and Saturn. No longer would human voices rise in song or human minds wrestle with the great questions of existence that have driven our species to explore, create, and wonder. The universe would become a place of pure physics once again, where events unfold according to mathematical laws without consciousness to interpret their meaning or beauty. The elegant spiral arms of distant galaxies would continue their stately rotation, but there would be no eyes to admire their graceful curves. The aurora on Jupiter's poles would continue to dance in response to the planet's magnetic field, but there would be no minds present to marvel at their ethereal beauty. This silence would not be a mere absence of sound, for sound cannot travel through the vacuum of space. Rather, it would be an absence of observation, interpretation, and wonder. The universe would continue to exist in all its mathematical glory, but there would be no consciousness present to appreciate the sublime order underlying the apparent chaos of cosmic evolution. And yet, in contemplating this cosmic silence, we are reminded of how precious and remarkable our current moment truly is. Right now, in this brief span of cosmic time, matter has organized itself on Earth into patterns capable of contemplating the very cosmos from which it emerged. Through human consciousness, the universe has developed the capacity to observe and understand itself, to create beauty and meaning from the raw materials of space, time, matter, and energy. This capacity for awareness and wonder is perhaps the most remarkable development in the 13.8 billion year history of our universe. It represents the cosmos awakening to its own existence, developing the ability to ask questions about its origins, its nature, and its ultimate destiny. In this sense, consciousness is not merely a byproduct of cosmic evolution, but perhaps its most significant achievement, the point at which the universe begins to know itself. The hypothetical disappearance of Earth would thus represent more than just the loss of a single planet orbiting an ordinary star. It would mean the elimination of the only known location where the universe has achieved self-awareness, where the fundamental forces and particles of nature have combined to create beings capable of love, creativity, and transcendent wonder at the beauty and mystery of existence itself. And mystery of existence itself. As we continue our gentle drift through this cosmic meditation, we find ourselves drawn to contemplate the more distant reaches of our celestial neighborhood, where the consequences of Earth's absence would unfold like slow ripples across an infinite pond. The gravitational dance that has connected our world to the broader cosmos extends far beyond the familiar boundaries of our solar system, reaching into the realm where our sun's influence gradually gives way to the ancient pull of neighboring stars. In the vast sphere of space that astronomers call the Oort cloud, that distant shell of icy bodies that marks the true edge of our solar system, Earth's disappearance would eventually register as the faintest of gravitational whispers. This cloud of comets, stretching perhaps a light year from our sun, contains billions of frozen remnants from the formation of our solar system. These ancient wanderers follow orbits so distant and slow that they complete their journeys around the sun over periods measured in millions of years. Earth's gravitational influence on these distant travelers has always been subtle, contributing tiny perturbations that accumulate over geological time. Without our planet's gentle nudges, some of these icy visitors might follow slightly different paths on their rare journeys into the inner solar system. A comet that might have blazed across Earth's skies in some distant future could instead pass harmlessly through the outer reaches of our solar system, its spectacular tail visible only to the distant stars. The closest of these stars, Proxima Centauri, lies more than 4 light-years away from our Sun. At this vast distance, Earth's gravitational influence has never been more than a mathematical abstraction, too weak to affect even the most sensitive measurements. Yet the gravitational waves generated by our planet's sudden disappearance would eventually reach this neighboring star system, carrying with them the news of our world's vanishing at the speed of light. 4 years and 3 months after Earth's disappearance, these ripples in space-time would wash over the Proxima Centauri system, causing immeasurably small distortions in the fabric of space around this red dwarf star and its recently discovered planets. Any hypothetical observers in that distant system would need gravitational wave detectors far more sensitive than anything humans have ever built to detect these cosmic whispers. Yet the information would be there, encoded in the geometry of space-time itself. The star Proxima Centauri, barely visible to the naked eye despite being our nearest stellar neighbour, would continue its slow stellar evolution completely unaware that a world capable of observing it had ceased to exist. This ancient red dwarf, with a lifespan measured in trillions of years, represents the kind of cosmic patience that dwarfs all human experience. Its nuclear fires burn so slowly and steadily that it will continue shining long after our Sun has exhausted its fuel and faded to a cold white dwarf. As we expand our view to encompass more distant stars, we encounter one of the most beautiful aspects of cosmic evolution. The constellation patterns that have guided human navigation and inspired countless stories would continue their slow dance across the sky, though there would be no observers left to appreciate their ancient choreography. The stars that form Orion, Ursa Major and Cassiopeia would continue their individual journeys through the galaxy, gradually altering these familiar patterns over hundreds of thousands of years. The proper motions of stars, those slow drifts across the celestial sphere that result from their orbital paths around the galactic center, would proceed exactly as they always have. Barnard's star, racing across our sky faster than any other known star, would continue its journey through the constellation Ophiuchus, approaching our solar system for a close encounter some 10,000 years in the future. At its closest approach, this red dwarf will come within about 4 light-years of the Sun, briefly becoming our nearest stellar neighbour before continuing on its way. Without Earth to observe this cosmic ballet, these stellar motions would become pure physics, mathematical trajectories governed by the gravitational influence of the Milky Way's dark matter halo and the complex dynamics of stellar interactions. The stars would continue their ancient orbits around the galactic center, completing their roughly 225 million-year journeys with mechanical precision, but there would be no consciousness present to map their positions or wonder at their destinations. The spiral arms of our galaxy, those majestic structures that sweep through space like frozen tsunamis of stars and gas, would continue their own rotation around the galactic center. These arms are not fixed structures, but rather density waves that move through the stellar population like traffic jams on a cosmic highway. Stars drift into and out of these arms over millions of years, experiencing periods of intense star formation when they encounter the dense gas clouds that characterize these regions. Our Sun, carrying its diminished family of planets, would continue its own journey through these spiral arms, currently moving through what astronomers call the local arm or Orion spur. In some 30 million years, our solar system will enter the Perseus arm, encountering higher densities of gas and dust that might trigger increased comet activity as gravitational perturbations stir the distant Oort cloud. These cosmic seasons, playing out over timescales that make geological ages seem brief, would unfold exactly as they always have, regardless of Earth's presence or absence. The supermassive black hole that lurks at the center of our galaxy, known as Sagittarius A star, would continue its gravitational dominance over the Milky Way's spiral structure. This cosmic monster, containing more than 4 million times the mass of our Sun, orchestrates the dance of hundreds of billions of stars through its immense gravitational influence. Recent observations have revealed that this black hole occasionally flares with X-ray emissions as it consumes nearby material, events that would continue to occur on their unpredictable schedule whether or not there were any observers left to detect them. The cosmic web itself, that vast network of dark matter filaments that connects galaxies across billions of light years, would continue its slow evolution driven by the expansion of the universe and the gravitational clustering of matter. Earth's disappearance would represent less than a quantum fluctuation in this grand structure, utterly insignificant compared to the dark matter halos that contain entire galaxy clusters. As we drift our contemplation toward even larger scales, we encounter the profound question of cosmic time and the patient unfolding of universal evolution. The universe has been expanding and cooling for nearly 14 billion years, and current models suggest it will continue this expansion for trillions of years to come. During this vast span of time, the cosmos will undergo transformations that make the formation and destruction of individual planets seem like brief, flickering moments in an eternal flame. The era of star formation that has characterized the universe for most of its history will gradually wind down as the raw materials for stellar birth become increasingly dispersed by cosmic expansion. In perhaps 1 trillion years, the last red dwarf stars will begin to form from the final clouds of hydrogen gas, marking the beginning of the end for the stellar age of cosmic history. After this, the universe will enter a much longer phase dominated by the slow evolution and eventual death of existing stars. During this unimaginably long stellar twilight, lasting perhaps 100 trillion years, the remaining stars will gradually exhaust their nuclear fuel and fade to white dwarfs, neutron stars, or black holes. The universe will become an increasingly cold and empty place, illuminated only by the occasional flash of matter falling into black holes, or the rare collision of stellar remnants. Yet even in this distant future, the gravitational waves generated by Earth's disappearance would still be propagating outward through space, carrying their message to whatever observers might exist in that dark and distant age. These cosmic ripples would have traveled so far by then that they would be encountering galaxies billions of light years from the Milky Way, regions of space that were beyond the observable universe at the time of Earth's existence. The information contained in these gravitational waves would paint a precise picture of our planet's physical characteristics for any civilization advanced enough to detect and decode them. The mass distribution within Earth's interior, the effects of our planet's rotation, even the gravitational influence of the Moon, all of this would be preserved in the mathematical structure of the space-time distortions radiating outward from our former location. This raises a profound question about the nature of information and its relationship to physical existence. In what sense can we say that Earth continues to exist if its gravitational signature propagates through the universe for eternity? The waves carry no matter, no energy in the traditional sense, yet they preserve a perfect mathematical description of our world's most fundamental physical properties. From the perspective of general relativity, information about Earth's existence becomes woven into the fabric of space-time itself, creating a kind of cosmic memory that persists long after the matter and energy that created it have been redistributed throughout the universe. This gravitational memory effect, predicted by Einstein's equations and recently confirmed through gravitational wave observations, suggests that the universe maintains a record of every mass that has ever existed within it. The philosophical implications of this cosmic bookkeeping extend far beyond the realm of physics into questions about the meaning of existence itself. If the universe preserves information about everything that has ever been, then perhaps nothing is ever truly lost, merely transformed from one state to another in the great conservation equations that govern reality. As we continue our meditation on these vast scales of space and time, we encounter the humbling reality of cosmic insignificance balanced against the extraordinary improbability of our existence. The observable universe contains at least 2 trillion galaxies, each harboring hundreds of billions of stars. The total number of planets in the cosmos likely exceeds the number of grains of sand on all the beaches of Earth, by factors that challenge human comprehension. Yet among all these countless worlds, Earth appears to be extraordinarily special. Our planet occupies what astronomers call the Goldilocks zone around our Sun, that narrow range of distances where temperatures allow liquid water to exist on a planetary surface. But this is only the first of many remarkable coincidences that have made our world suitable for the emergence and evolution of complex life. Earth's size gives it just enough gravity to retain a substantial atmosphere without becoming so massive that it captures enormous amounts of hydrogen and helium, like the gas giant planets. Our world's 24-hour rotation period prevents the extreme temperature variations that would occur if Earth rotated much more slowly or quickly. The presence of our unusually large moon stabilizes Earth's axial tilt, preventing dramatic climate changes that might otherwise make complex life impossible. The geological activity that continues to reshape Earth's surface depends on a delicate balance of factors, including our planet's size, its distance from the Sun, and the presence of radioactive elements in Earth's core that provide the heat necessary to drive plate tectonics. This geological dynamism recycles carbon between the atmosphere and the interior, maintaining the chemical balance necessary for life while generating the magnetic field that protects our atmosphere from being stripped away by the solar wind. The probability that all these factors would align to create a world suitable for life appears vanishingly small. Current estimates suggest that Earth-like planets may occur around fewer than 1 star in a billion, making our world almost unimaginably rare in the cosmic census of planets. If these estimates are correct, then the nearest world similar to Earth might lie hundreds or even thousands of light years away. This extraordinary rarity imbues Earth's hypothetical disappearance with a significance that transcends mere orbital mechanics. Our planet represents the only confirmed example of a world where matter has organized itself into patterns complex enough to contemplate its own existence. The biosphere that has flourished here for billions of years contains solutions to the challenges of survival and reproduction that life has discovered through countless experiments across geological time. The diversity of life on Earth encompasses millions of species, each representing a unique approach to the fundamental problems of existence. From the photosynthetic bacteria that first filled our atmosphere with oxygen to the complex neural networks that enable human consciousness, life on our planet has explored virtually every possible strategy for extracting order from chaos and creating meaning from the raw materials of chemistry and physics. The disappearance of Earth would eliminate not just individual species or even entire ecosystems, but the entire library of biological information that evolution has written over billions of years. Each gene, each protein structure, each behavioral adaptation represents knowledge gained through the trial and error of natural selection, insights into the fundamental principles that govern the organization of matter and energy into living systems. Human consciousness adds another layer of extraordinary improbability to Earth's cosmic significance. Through our minds, the universe has developed the capacity to observe and understand itself, to create art and music and literature that capture the beauty and mystery of existence. We represent the cosmos awakening to its own nature, matter becoming aware of the forces and principles that govern its behavior. This capacity for consciousness and creativity extends throughout the animal kingdom in ways that continue to surprise and delight researchers. The complex social behaviors of dolphins and whales, the problem-solving abilities of octopi and corvids, the intricate communication systems of birds and bees, all represent different experiments in awareness and intelligence that have emerged from Earth's evolutionary laboratory. The loss of this biological and cognitive richness would impoverish the universe in ways that transcend mere physics. Without Earth, the cosmos would become a place of pure mathematical relationships, where events unfold according to physical laws without consciousness, to interpret their meaning or find beauty in their operation. The elegant spiral structure of galaxies would continue its stately rotation, but there would be no minds present to admire its graceful curves or wonder at the forces that maintain its stability. Yet as we contemplate this potential cosmic impoverishment, we must also acknowledge the profound resilience and creativity that characterizes the universe itself. The same physical processes that gave rise to Earth and its biosphere continue to operate throughout the cosmos. New stars are being born in stellar nurseries across distant galaxies, and around these stars, new planetary systems are condensing from the cosmic debris of stellar birth and death. The heavy elements necessary for rocky planets and complex chemistry are continuously being manufactured in the nuclear furnaces of massive stars and scattered throughout space by supernovae explosions. The carbon atoms that form the backbone of biological molecules, the oxygen that makes water possible, the calcium and phosphorus that build bones and shells. All of these elements are being created and distributed by cosmic processes that will continue for trillions of years. Given enough time and the right conditions, matter might once again organize itself into patterns capable of consciousness and wonder on worlds we cannot yet imagine orbiting stars not yet born. The emergence of life and intelligence may be extraordinarily rare, but in a universe containing trillions upon trillions of planets, even the most improbable events become inevitable given sufficient opportunity. This cosmic perspective offers a kind of comfort in the face of Earth's hypothetical disappearance. While our particular world and everything it contains would be lost, the universe would continue its patient exploration of complexity and consciousness across vast reaches of space and time. New forms of life might emerge that we cannot envision, new types of intelligence that would ask questions we have never thought to pose. The atoms that currently constitute our planet and everything on it would continue to participate in this cosmic evolution, becoming incorporated into new stars and planets as the universe continues its expansion and cooling. The carbon in our bodies, the calcium in our bones, the iron in our blood, all of these elements would eventually find their way into future worlds where they might once again become part of living systems. In this sense, Earth's disappearance would represent not an ending, but a transformation, a changing of the cosmic guard in the universe's ongoing exploration of what is possible when matter and energy interact according to the fundamental laws of physics. We are made of star stuff, as Carl Sagan so beautifully expressed, and when our world eventually returns to the cosmos, that star stuff will carry with it the potential for new forms of organization and awareness. The mathematical relationships that govern orbital mechanics, stellar evolution, and galactic dynamics would continue to operate exactly as they always have, indifferent to the particular arrangements of matter they describe. Yet within the framework of these eternal laws, the universe would continue to create new opportunities for complexity, consciousness, and wonder to emerge from the fundamental particles and forces that constitute reality. As our meditation on cosmic consequences draws toward its gentle conclusion, we find ourselves face to face with one of the most profound paradoxes of human existence. We are simultaneously insignificant specks in an unimaginably vast cosmos, and the only known observers capable of contemplating that very vastness. We are arrangements of atoms that have become aware of their atomic nature, patterns of matter and energy that have developed the capacity to wonder at the forces that shape them. This dual nature of cosmic insignificance and absolute importance lies at the heart of what makes Earth's hypothetical disappearance so poignant. From the perspective of galactic evolution or cosmological time, our world represents less than a rounding error in the universe's grand calculations. Yet, from the perspective of consciousness and meaning, Earth represents everything we have ever known or can hope to know about existence itself. The contemplation of our planet's possible absence thus becomes more than an exercise in astrophysics. It becomes a meditation on the nature of consciousness, on the extraordinary improbability that matter should organize itself in ways that allow it to contemplate its own existence, and on the profound responsibility that comes with being the universe's only known observers. If Earth were to vanish tomorrow, the cosmic consequences would unfold exactly as the laws of physics predict. The Moon would begin its solitary journey around the Sun. The other planets would continue their ancient orbits with barely perceptible changes, and gravitational waves would carry news of our world's disappearance to the farthest reaches of space and time. The universe would continue its patient expansion and evolution, creating new stars and planets, and opportunities for complexity to emerge. The mathematical relationships that describe how matter and energy behave would remain unchanged, operating with the same elegant precision they have maintained for nearly 14 billion years. Yet something irreplaceable would be lost, something that might not emerge again for billions of years, if ever. The particular combination of circumstances that allowed Earth to become a haven for life and consciousness represents a cosmic lottery win of almost unimaginable proportions. The loss of this achievement would leave the universe a lonelier place, though there would be no consciousness remaining to feel that loneliness. In the end, perhaps the most profound consequence of Earth's disappearance would be the silence that would settle over our corner of the cosmos. No longer would radio telescopes scan the heavens for signs of intelligence among the stars. No longer would spacecraft venture forth to explore the moons of distant planets. No longer would human voices rise in song or human minds grapple with the great questions that have driven our species to create and explore and wonder. This silence would not be merely an absence of sound, for sound cannot travel through the vacuum of space. Rather, it would be an absence of observation, interpretation, and wonder. The universe would continue to exist in all its mathematical glory, but there would be no consciousness present to appreciate the sublime order underlying the apparent chaos of cosmic evolution. And yet, in contemplating this cosmic silence, we are reminded of how precious and remarkable our current moment truly is. Right now, in this brief span of cosmic time, matter has organized itself on Earth into patterns capable of contemplating the very universe from which it emerged. Through human consciousness and the consciousness of countless other species that share our world, the cosmos has developed the capacity to know and understand itself. This awakening of the universe to its own existence may be the most remarkable development in the entire history of cosmic evolution. It represents matter becoming aware of the principles that govern its behavior, energy developing the capacity to contemplate its own nature, and space and time learning to observe their own curvature and flow. The hypothetical disappearance of Earth would thus eliminate more than just a single planet orbiting an ordinary star in an unremarkable region of a typical galaxy. It would silence the only known voice the universe has developed to speak of its own beauty, to wonder at its own mysteries, and to create meaning from the cosmic dance of matter and energy that has been unfolding for nearly 14 billion years. In this profound silence lies perhaps the deepest lesson of our cosmic meditation. We are not separate from the universe, but rather the way the universe has developed to experience itself. We are the cosmos become conscious, the stars awakening to their own light, the void learning to marvel at its own vastness and complexity. Our existence, however brief it may be on cosmic timescales, represents a triumph of organization over entropy, of meaning over randomness, of consciousness over the vast indifference of space and time. We are living proof that the universe contains not just matter and energy and the forces that govern their interaction, but also the potential for beauty, wonder, love, and transcendent awareness of the profound mystery of being. In the gentle darkness of this moment, as we drift towards sleep surrounded by the infinite cosmos, we can take comfort in knowing that we are not just observers of the universe, but participants in its grandest experiment. We are the way 13 billion years of cosmic evolution has learned to ask questions about its own nature and to find in those questions not just answers, but also wonder, meaning, and an inexhaustible source of beauty that transforms mere existence into something approaching the sacred. The stars that shine in the darkness above us shine with the same nuclear fire that burns in our own hearts. The atoms that form our bodies were forged in stellar furnaces and scattered across space by supernovae explosions that illuminated distant galaxies billions of years ago. We are quite literally made of star stuff, but we are star stuff that has become aware of its stellar origins and capable of looking back across space and time to contemplate the cosmic processes that gave birth to everything we know and cherish. And so, as we settle into the peaceful embrace of sleep, we can rest in the knowledge that we are part of something infinitely vast and beautiful, something that has been unfolding for eons and will continue long after our brief moment in the cosmic story has passed. We are the universe dreaming of itself, consciousness arising from the ancient dance of matter and energy, meaning emerging from the mathematical symphony that has been playing since the first moment of time began. In this cosmic lullaby, we find our place not as separate beings struggling against an indifferent universe, but as integral notes in the greatest composition ever written, temporary but essential expressions of the cosmos learning to know and love itself through the miracle of consciousness that we carry within us, like a sacred flame passed down through billions of years of stellar evolution. Sleep now, knowing that you are part of this infinite story, this cosmic awakening, this grand experiment in what is possible when matter and energy dance together according to the elegant laws that govern all of existence. Dream of stars and planets and galaxies spinning through the darkness, and know that you are not separate from this cosmic dance, but rather its most beautiful expression, the way the universe has learned to wonder at its own mystery, and find in that wonder something approaching perfect peace. Tonight, we drift deeper into the profound question that has guided our cosmic journey, exploring the ripples that would spread through space and time long after Earth's hypothetical disappearance has faded into the mathematical memory of the universe. As we settle into this gentle exploration, let us turn our attention to the more distant consequences that would unfold across scales of time so vast they challenge the very limits of human imagination. In the realm of stellar evolution, our sun would continue its ancient nuclear burning with mechanical precision, fusing hydrogen into helium in its core at a rate of approximately 600 million tons per second. This cosmic furnace has been burning steadily for nearly 5 billion years, and it will continue for another 5 billion more, completely indifferent to the presence or absence of any particular world orbiting within its gravitational embrace. The solar neutrinos that stream outward from these nuclear reactions would continue their ghostly journey through space, carrying with them no information about the planets they once illuminated. The sun's magnetic field, that complex and ever-changing structure that creates sunspots and solar flares, would continue its 11-year cycle of reversal and renewal. The solar wind, that constant stream of charged particles flowing outward at speeds approaching 1 million miles per hour, would encounter no obstacle where Earth once stood, flowing unimpeded through the space our planet once occupied. The delicate dance between solar activity and planetary magnetospheres that creates aurora on worlds throughout our solar system would continue unchanged on Jupiter, Saturn, and the other giant planets that possess substantial magnetic fields. As we expand our contemplation to encompass the broader architecture of our solar system, we encounter the fascinating realm of orbital resonances and gravitational stability. These invisible mathematical relationships that connect the motions of celestial bodies operate like cosmic music, creating harmonies and rhythms that have maintained the orderly structure of planetary orbits for billions of years. Earth's participation in this celestial symphony has always been subtle but real, contributing tiny gravitational nudges that help maintain the long-term stability of the entire system. The asteroid belt, That vast collection of rocky debris orbiting between Mars and Jupiter would experience perhaps the most noticeable long-term changes from Earth's absence. Currently, our planet's gravitational influence helps to shepherd certain asteroids away from potentially dangerous Earth-crossing orbits, contributing to the complex web of gravitational interactions that shapes the evolution of these ancient remnants from the solar system's formation. Without Earth's gentle guidance, some asteroids might gradually drift into different orbital configurations over millions of years, though these changes would unfold so slowly as to be imperceptible on human timescales. The Trojan asteroids, those fascinating objects that share Jupiter's orbit while maintaining stable positions 60 degrees ahead of and behind the giant planet, would continue their eternal dance around the Lagrange points of the Jupiter-Sun system. These gravitational islands of stability represent some of the most elegant solutions to the three-body problem in celestial mechanics, demonstrating how mathematical precision can create oases of order in what might otherwise be chaotic gravitational interactions. Jupiter itself, that magnificent giant whose mass exceeds that of all other planets combined, would continue to serve as the solar system's gravitational shepherd, protecting the inner planets from cometary impacts and maintaining the structural integrity of the entire planetary arrangement. The Great Red Spot, that enormous storm larger than Earth that has raged in Jupiter's atmosphere for centuries, would continue its ancient circulation, driven by the same atmospheric dynamics that have shaped the planet's weather patterns since the dawn of the solar system. The four largest moons of Jupiter, those Galilean satellites discovered by Italian astronomer Galileo Galilei over 4 centuries ago, would maintain their intricate orbital dance around their massive parent. Io would continue its volcanic eruptions, powered by the tidal heating created by Jupiter's immense gravitational field. Europa's subsurface ocean would remain hidden beneath its icy crust, potentially harboring conditions suitable for life in the cold darkness far from the sun. Ganymede and Callisto would continue their stately orbits, ancient worlds whose surfaces record the history of impacts and geological processes that shaped the early solar system. Saturn's magnificent ring system would continue its slow evolution, with particles constantly colliding, fragmenting, and reorganizing under the influence of the planet's gravity and the gravitational perturbations of its many moons. The rings themselves are likely temporary features on astronomical timescales, gradually spiraling inward toward the planet or being dispersed into space by gravitational interactions. Yet this process unfolds over periods measured in hundreds of millions of years, far longer than Earth's absence would represent in the cosmic calendar. The outer planets, Uranus and Neptune, those ice giants orbiting in the frigid outer reaches of our solar system, would continue their patient journeys around the Sun, completing their orbits over periods of 84 and 165 years respectively. These distant worlds, with their exotic atmospheric compositions of hydrogen, helium, and various ices, represent laboratories for studying planetary formation and evolution under conditions vastly different from those in the inner solar system. Uranus, with its unusual axial tilt that causes it to essentially roll along its orbital path like a cosmic ball, would maintain this unique orientation that likely resulted from a massive impact early in the solar system's history. Neptune, whose existence was predicted mathematically before it was observed telescopically, would continue to demonstrate the power of gravitational theory to reveal hidden truths about the cosmos through pure mathematical reasoning. The dwarf planet Pluto, demoted from full planetary status but no less fascinating for its reclassification, would continue its elliptical journey through the outer solar system in the company of its companion moon Charon. This binary system, where both objects orbit around a common center of mass located between them, represents a unique configuration in our solar system and provides insights into the formation and evolution of binary planetary systems throughout the galaxy. Beyond the orbit of Neptune lies the Kuiper Belt, that vast reservoir of icy bodies that extends from about 30 to 50 times Earth's distance from the Sun. This region contains thousands of objects larger than 100 kilometers in diameter, remnants from the formation of the solar system that have remained largely unchanged for billions of years. These primitive bodies preserve information about the conditions that existed in the early solar nebula, the disk of gas and dust from which all the planets formed. The gravitational influence of Earth on these distant objects has always been vanishingly small. Yet even these tiny perturbations contribute to the complex orbital evolution that shapes the Kuiper belt over cosmic time. Without Earth's minute gravitational nudges, some of these objects might follow slightly different evolutionary paths, though the changes would be so subtle as to be undetectable except through the most precise long-term observations. As we venture even further from the Sun, we encounter the Oort cloud, that spherical shell of comets that may extend halfway to the nearest star. This vast repository contains perhaps 1 trillion icy bodies, the most distant gravitationally bound objects in our solar system. The comets that occasionally visit the inner solar system, creating spectacular displays as they approach the Sun and their ices sublimate into glowing tails, originate from this distant realm. The gravitational perturbations that occasionally nudge these comets out of the Oort cloud and into the inner solar system come primarily from passing stars and the galactic tide created by the Milky Way's gravitational field. Earth's contribution to this process has always been negligible, yet the absence of our planet would represent one less source of the tiny gravitational influences that shape the long-term evolution of cometary orbits over periods measured in millions of years. The study of these distant comets provides insights into the chemical composition of the early solar system, as these objects have remained frozen in the deep cold of space since their formation. When comets approach the Sun and begin to outgas, they release water vapor, carbon dioxide, and various organic compounds that may have played a crucial role in delivering the raw materials for life to the early Earth. This cosmic delivery system would continue to operate exactly as it always has, regardless of whether there were any planets remaining to receive these precious cargoes. As our contemplation expands to encompass the motion of our entire solar system through the galaxy, we encounter timescales and distances that truly dwarf human experience. Our Sun, carrying its family of planets and smaller bodies, orbits the center of the Milky Way at a speed of approximately 250 kilometers per second, completing one galactic orbit roughly every 225 million years. This cosmic year, known as a galactic year, provides a natural timescale for measuring the longest geological processes that shape planetary evolution. During Earth's history, our planet has completed approximately 20 galactic orbits, witnessing the rise and fall of countless species and the gradual evolution of continents and oceans. The fossil record preserves evidence of mass extinctions and evolutionary radiations that coincided with our solar system's passage through the spiral arms of the galaxy, where encounters with dense clouds of gas and dust may have triggered climate changes through their effects on the Sun's energy output. The local group of galaxies, that gravitationally bound collection of more than 80 galaxies dominated by the Milky Way, Andromeda, and Triangulum galaxies, would continue its slow evolution, driven by the mutual gravitational attraction of its members. The Andromeda Galaxy, approaching our Milky Way at a speed of approximately 250,000 miles per hour, would continue its inexorable journey toward an eventual merger with our galaxy, some 4 to 5 billion years in the future. This galactic collision, while dramatic in name, would unfold with such gentleness that any planetary systems surviving to witness it would likely remain intact. The vast distances between individual stars ensure that direct collisions would be extraordinarily rare, though the gravitational disruption might alter the orbits of planets around their parent stars and reshape the structure of both galaxies into a new elliptical configuration that astronomers have dubbed Milkomeda. The dark matter halo that encompasses our galaxy, invisible except through its gravitational effects, would continue to shape the large-scale structure of the cosmos through its participation in the cosmic web of dark matter filaments that connects galaxies across billions of light years. This invisible scaffolding, comprising approximately 85% of all matter in the universe, provides the gravitational foundation upon which the visible structures we observe have formed and evolved. Earth's contribution to this cosmic architecture has always been infinitesimally small, yet our planet's atoms are part of the ordinary matter that makes up stars, planets, and the gas clouds between them. The hydrogen in our oceans, forged in the first minutes after the Big Bang, connects us directly to the cosmic processes that created the chemical elements necessary for complexity and life. The heavier elements in our bodies were manufactured in the nuclear furnaces of ancient stars and scattered through space by supernovae explosions that enrich the interstellar medium with the raw materials for planetary formation. This cosmic recycling process ensures that the atoms comprising Earth and everything on it are not permanent residents of our world, but rather temporary visitors on a cosmic journey that began with the Big Bang and will continue long after our Sun has exhausted its nuclear fuel. The carbon atoms that form the backbone of biological molecules, the oxygen that enables cellular respiration, the calcium and phosphorus that build bones and shells, all of these elements will eventually return to the cosmic inventory of materials available for the construction of future stars and planets. The timeline for this cosmic recycling extends far beyond the current age of the universe. When our Sun exhausts the hydrogen fuel in its core, some 5 billion years from now, it will expand into a red giant star, likely engulfing and vaporizing any remaining inner planets. The outer layers of the Sun will be expelled into space, creating a beautiful planetary nebula that will glow for thousands of years as it expands into the interstellar medium. The white dwarf star that remains after this process will slowly cool over trillions of years, eventually becoming a cold, dark remnant no larger than Earth but containing more than half the mass of our current Sun. During this cooling process, the carbon and oxygen that make up the white dwarf's interior will gradually crystallize, creating what is essentially a cosmic diamond larger than our entire planet. Even this seemingly permanent stellar remnant will not endure forever. Quantum mechanical processes operating over unimaginably long timescales will eventually cause protons to decay, transforming the white dwarf into a cloud of electrons, positrons, and photons. The timescale for this process is so vast that it dwarfs the current age of the universe by factors that challenge human comprehension, involving periods measured in 10 to the 34th years or more. Yet even these astronomical timescales pale in comparison to the ultimate fate of the universe itself. Current observations suggest that the expansion of space is accelerating, driven by the mysterious dark energy that comprises approximately 70% of the cosmos. If this acceleration continues, the universe will enter an era of exponential expansion that will eventually separate all gravitationally bound structures, leaving each galaxy isolated in an ever-expanding void. During this cosmic diaspora, individual galaxies will continue to evolve in isolation, their stars gradually exhausting their nuclear fuel and fading into darkness. The era of star formation will slowly wind down as the raw materials for stellar birth become increasingly dispersed by the expansion of space. Eventually, the universe will enter what cosmologists call the degenerate era, dominated by white dwarf stars, neutron stars, and black holes slowly evaporating through Hawking radiation. Even black holes, those ultimate gravitational prisons from which not even light can escape, will eventually evaporate completely through the quantum mechanical process described by Stephen Hawking. The timescale for this evaporation depends on the mass of the black hole, with stellar mass black holes requiring approximately 10 to the power of 67 years to disappear entirely. Supermassive black holes like those found at the centers of galaxies will persist for periods approaching 10 to the 100th power years before finally radiating away their last particles. In the final analysis, the universe appears destined to end not with dramatic collapse, but with gradual heat death. reaching a state of maximum entropy where no further work can be extracted from the cosmic energy budget. This ultimate fate, occurring over timescales that make the current age of the universe seem like the briefest instant, represents the final victory of the second law of thermodynamics over all forms of organization and complexity. Yet within this vast cosmic timeline, the brief flowering of complexity that we observe around us represents something truly remarkable. The formation of galaxies, stars, and planets, the emergence of life and consciousness, the development of science and art and philosophy. All of these achievements occur during a tiny fraction of cosmic time when conditions happen to be suitable for the organization of matter and energy into increasingly complex patterns. The window of opportunity for complexity in the universe may be closing even as we contemplate it. The accelerating expansion of space is gradually making it more difficult for matter to come together to form new structures. The era of galaxy formation appears to be ending, and the epoch of stellar birth may be more than halfway complete. We exist during what may be the brief golden age of cosmic complexity, when the universe has cooled enough to allow the formation of complex structures, but has not yet expanded to the point where such structures become impossible to maintain. This cosmic perspective imbues Earth's hypothetical disappearance with a poignancy that transcends mere physics. Our planet represents one of the universe's most successful experiments in complexity, a world where matter has organized itself into patterns capable of self-awareness and creative expression. The loss of this achievement would not affect the ultimate fate of the cosmos, but it would eliminate one of the most remarkable developments in the entire history of universal evolution. The probability that such complexity could emerge appears to be extraordinarily small. The precise balance of physical constants that allows atoms to form, stars to shine, and planets to maintain stable orbits represents a cosmic fine-tuning that physicists are still struggling to understand. Even tiny changes in the strength of fundamental forces or the masses of elementary particles could result in a universe where complexity never emerges at all. The anthropic principle, which observes that the universe appears to be precisely configured to allow the existence of conscious observers, raises profound questions about the nature of reality itself. Some interpretations suggest that we exist in one of countless parallel universes, most of which lack the precise conditions necessary for complexity and consciousness. Others propose that the universe's apparent fine-tuning reflects deeper principles that we have yet to discover. Regardless of the ultimate explanation for cosmic fine-tuning, Earth's existence represents a remarkable convergence of favorable conditions that allowed complexity to flourish over billions of years. The stable nuclear burning of our Sun, the protective influence of Jupiter's gravity, the presence of liquid water on our planet's surface, the geological processes that maintain chemical balance, all of these factors had to align precisely to create the conditions where life could emerge and evolve into the rich biosphere we observe today. The contemplation of Earth's rarity in the cosmic census of planets reveals something profound about our relationship to the universe. We are not separate from the cosmos, but rather its most complex known expression, the way 14 billion years of cosmic evolution has learned to contemplate its own nature and find beauty in its own mathematical structure. This perspective transforms our understanding of what it means to exist. We are temporary arrangements of atoms that were forged in stellar furnaces and scattered through space by cosmic explosions. Yet these same atoms have organized themselves in ways that allow them to ponder their own stellar origins and reach toward an understanding of the forces that shape them. The human brain, containing approximately 86 billion neurons connected by trillions of synapses, represents one of the most complex structures known to exist anywhere in the universe. Through these neural networks, the cosmos has developed the capacity for memory, creativity, and abstract thought. We can compose music that moves the soul, create art that captures beauty, and formulate scientific theories that reveal the hidden order underlying apparent chaos. This capacity for consciousness and creativity extends throughout the biological world in ways that continue to surprise and delight researchers. The complex social behaviors of dolphins and whales, the problem-solving abilities of octopi and elephants, the intricate communication systems of birds and bees, all represent different experiments in awareness and intelligence that have emerged from Earth's evolutionary laboratory. The study of animal cognition reveals that consciousness may be far more widespread in the natural world than humans once assumed. From the tool use of chimpanzees and crows, to the apparent self-awareness demonstrated by dolphins and elephants when presented with mirrors, the evidence suggests that many species possess rich inner lives and sophisticated cognitive abilities. Even plants, long considered passive organisms that simply respond to environmental stimuli, are now known to engage in complex information processing and communication. Trees in forests share nutrients and warning signals through underground fungal networks, creating what researchers call the Wood Wide Web. These biological internet connections allow entire forest ecosystems to coordinate their responses to environmental challenges, demonstrating that intelligence and communication can take forms very different from animal consciousness. The disappearance of Earth would eliminate not just individual species, but the entire library of biological solutions that evolution has discovered over billions of years. Each adaptation, from the echolocation of bats to the magnetic navigation of sea turtles, represents knowledge gained through countless generations of natural selection, insights into the fundamental principles that govern the organization of living systems. The genetic code itself, that universal language of DNA that underlies all terrestrial life, embodies information about biochemical processes that has been refined and tested over geological time. The proteins that catalyze cellular reactions, the regulatory networks that control gene expression, the immune systems that protect organisms from disease, all of these biological innovations represent technological achievements that human science is only beginning to understand and appreciate. The loss of this biological richness would impoverish the universe in ways that transcend scientific knowledge. Earth's biosphere represents a living library of creativity and innovation, a testament to the universe's capacity for generating beauty and complexity from the simple interactions of matter and energy according to physical law. The coral reefs that bloom like underwater gardens in tropical seas, the vast migrations of whales and birds that connect distant ecosystems, the symbiotic relationships between species that create ecological networks of stunning intricacy. All of these phenomena demonstrate that the universe contains not just matter and energy, but also the potential for cooperation, beauty, and harmony on scales ranging from the molecular to the planetary. Human culture adds another layer of complexity to this cosmic achievement. Through language, art, music, and literature, our species has created meaning from the raw materials of experience, transforming the chemical reactions of neural activity into symphonies, paintings, poems, and scientific theories that capture aspects of existence that cannot be reduced to pure physics. The mathematical equations that describe the behavior of subatomic particles and the expansion of the universe become, in human hands, tools for understanding and appreciating the profound order that underlies reality. The same physical processes that govern stellar evolution and galactic dynamics also generate the neural activity that allows human consciousness to contemplate these cosmic phenomena and find in them sources of wonder and meaning. This transformation of physical processes into conscious experience represents perhaps the most remarkable development in the entire history of cosmic evolution. Through human minds and the minds of other conscious beings that share our planet, the universe has learned to observe and understand itself, to create beauty from chaos, and to find meaning in the vast expanse of space and time. The hypothetical disappearance of Earth would thus eliminate more than just a single planet orbiting an ordinary star. It would silence the only known voice the universe has developed to speak of its own beauty, to wonder at its own mysteries, and to transform the mathematical relationships that govern cosmic evolution into sources of meaning and transcendence. This cosmic silence would not be merely an absence of sound, for sound cannot travel through the vacuum of space. Rather, it would be an absence of observation, interpretation, and creative response to the magnificent structure of reality. The elegant spiral arms of distant galaxies would continue their stately rotation, but there would be no consciousness present to admire their graceful curves or compose poems inspired by their beauty. The aurora that dance above the poles of magnetized planets would continue their ethereal displays, but there would be no minds present to witness their ghostly light or feel moved by their otherworldly beauty. The intricate orbital mechanics that govern the motion of planets and moons would continue to operate with mathematical precision, but there would be no consciousness present to discover the equations that describe these motions, or to find in those equations a source of intellectual satisfaction and aesthetic pleasure. Yet, in contemplating this potential cosmic silence, we are reminded of how precious and improbable our current moment truly is. Right now, in this brief span of cosmic time, matter has organized itself on Earth into patterns capable of contemplating the very universe from which it emerged. We represent the cosmos awakening to its own existence, learning to appreciate its own beauty, and developing the capacity to create meaning from the raw materials of physics and chemistry. This awakening is not merely a human phenomenon, but extends throughout the web of life that encompasses our planet. Every organism that responds to its environment, every ecosystem that maintains its balance through feedback mechanisms, every symbiotic relationship that creates mutual benefit. All of these biological phenomena represent the universe, learning to organize itself in increasingly sophisticated ways. The emergence of consciousness from this biological foundation represents a quantum leap in cosmic evolution, the point at which the universe develops the capacity for self-reflection and creative expression. Through conscious minds, the cosmos can appreciate its own beauty, ponder its own mysteries, and create art and music and literature that celebrate the profound mystery of existence itself. This capacity for consciousness and creativity appears to be extraordinarily rare in the cosmic inventory of possibilities. The precise conditions necessary for the emergence of complex life, let alone conscious intelligence, require such an unlikely convergence of favorable factors that Earth may represent one of the universe's most precious achievements. As we drift toward the conclusion of our cosmic meditation, we find ourselves contemplating the profound responsibility that comes with being the universe's known observers. We are the custodians of consciousness in a cosmos that may be largely devoid of awareness, the guardians of meaning in a reality that operates according to mathematical laws, indifferent to the particular arrangements of matter and energy they govern. This responsibility extends beyond mere preservation of our own existence to encompass the cultivation and celebration of consciousness wherever it may be found. The protection of biodiversity becomes not just an environmental imperative, but a cosmic duty, a recognition that every species represents a unique experiment in awareness and intelligence that took millions of years to develop. The pursuit of knowledge through science becomes an act of cosmic gratitude, a way of honoring the extraordinary circumstances that allowed matter to organize itself in ways that permit the investigation of natural law. The creation of art and music and literature becomes a celebration of the universe's capacity for beauty and meaning, a transformation of physical processes into experiences that touch the deepest levels of conscious awareness. The search for extraterrestrial intelligence takes on profound significance in this context, representing humanity's attempt to discover whether consciousness has emerged elsewhere in the cosmos, or whether Earth truly stands alone as the universe's only known observer. The detection of even simple microbial life on other worlds would provide reassurance that the emergence of complexity is not unique to our planet, while the discovery of intelligent civilizations would suggest that consciousness may be a more common feature of cosmic evolution than current evidence indicates. As we approach the gentle conclusion of our journey through space and time, we return to the fundamental question that has guided our exploration. If Earth were to suddenly vanish, what would the universe do? We have seen that the cosmic consequences would unfold exactly as the laws of physics predict. creating subtle ripples that would propagate through space and time while leaving the grand structure of reality largely unchanged. The Moon would begin its solitary orbit around the Sun, eventually settling into a trajectory that might bring it into gravitational encounters with other planets over geological time. The other worlds in our solar system would continue their ancient dances around our star with barely perceptible alterations, while the Sun itself would continue its nuclear burning with complete indifference to the absence of any particular planet. Gravitational waves would carry news of Earth's disappearance to the farthest reaches of the observable universe, encoding in their mathematical structure a permanent record of our planet's physical characteristics. These cosmic ripples would propagate outward for eternity, carrying information about Earth's existence to galaxies billions of light years away, long after any electromagnetic trace of our world had faded into the cosmic background. The universe would continue its patient expansion and evolution, creating new stars and planets and opportunities for complexity to emerge over timescales that dwarf human comprehension. The physical laws that govern cosmic behavior would remain unchanged, operating with the same elegant precision they have maintained for nearly 14 billion years. Yet something irreplaceable would be lost, something that represents one of the most remarkable developments in the entire history of universal evolution. Earth's biosphere, with its rich diversity of life and consciousness, embodies solutions to the challenges of existence that took billions of years to develop through the patient process of natural selection. The disappearance of this biological library would eliminate countless experiments in organization and awareness, from the photosynthetic machinery that powers the base of Earth's food webs to the complex neural networks that enable human consciousness and creativity. Each species that has ever lived represents a unique approach to the fundamental problems of survival and reproduction, a particular strategy for extracting order from chaos and creating meaning from the raw materials of chemistry and physics. Human consciousness adds a dimension of cosmic significance that transcends biology, representing the point at which the universe develops the capacity for self-awareness and creative expression. Through human minds, the cosmos has learned to appreciate its own beauty, to investigate its own structure through scientific inquiry, and to create art and music and literature that transform physical processes into experiences of meaning and transcendence. The loss of this capacity for consciousness and creativity would thus represent more than just the extinction of a particular species or the end of a single civilization. It would mean the elimination of the only known location where the universe has achieved self-awareness, where the fundamental particles and forces of nature have combined to create beings capable of love, wonder, scientific discovery, and artistic expression. The silence that would settle over our corner of the cosmos following Earth's disappearance would be profound in ways that transcend mere acoustics. It would represent the end of observation, the cessation of inquiry, the final quiet that comes when there are no longer any minds present to ask questions about the nature of existence or to find beauty in the mathematical relationships that govern cosmic evolution. This silence would encompass more than human consciousness, the complex vocalizations of whales as they navigate the world's oceans, the intricate songs of birds that fill our forests with music, the subtle chemical communications between trees in ancient woodlands. All of these forms of biological expression would vanish along with the ecosystems that sustained them for millions of years. The scientific instruments that humanity has scattered throughout the solar system would continue their observations for a time, dutifully recording measurements and transmitting data to receivers that would no longer exist. The Voyager spacecraft, now traveling through interstellar space, would carry their golden records ever farther from the Sun, bearing messages from a civilization that would have become nothing more than a gravitational memory preserved in the structure of space-time. The James Webb Space Telescope, positioned at the Earth-Sun L2 Lagrange point, would find itself in an unstable orbit following the disappearance of our planet. Without the gravitational balance point created by Earth and Sun working together, This magnificent instrument would begin to drift, its careful positioning disrupted by the sudden absence of the world it was designed to serve. The telescope might continue functioning for months or years, capturing images of distant galaxies and nebulae that would be recorded but never observed by human eyes. The International Space Station, if it happened to be on the night side of Earth at the moment of our planet's disappearance, would suddenly find itself in solar orbit rather than Earth orbit. Any astronauts aboard would face the profound loneliness of being the last representatives of human consciousness in a cosmos that had suddenly become infinitely more empty. Their life support systems would continue operating according to their programming, but there would be nowhere to return home to. No mission control to guide their activities. No world waiting to celebrate their achievements. These human artifacts, scattered throughout the solar system, would become archaeological remnants of a vanished civilization, technological fossils that might one day be discovered by explorers from other worlds. The lunar modules and rovers left on the moon's surface would remain there indefinitely, preserved in the airless environment as humanity's final footprints in the cosmic dust. As we drift deeper into contemplating these consequences, we encounter the question of cosmic memory and information preservation. Einstein's general relativity tells us that mass and energy curve the fabric of space-time, creating gravitational fields that influence the motion of all nearby objects. Earth's sudden disappearance would create a unique signature in the gravitational wave background of the universe, a pattern that would propagate outward at the speed of light, carrying precise information about our planet's mass, rotation, and internal structure. This gravitational information would be preserved with perfect fidelity, encoded in the geometry of space-time itself. Any civilization advanced enough to detect and decode these waves would be able to reconstruct detailed knowledge about Earth's physical characteristics, even millions of years after our world had vanished. In this sense, Earth would achieve a form of immortality, its existence permanently recorded in the fundamental structure of the universe. The conservation laws that govern physics ensure that the energy equivalent of Earth's mass cannot simply disappear. The famous equation E equals mc squared tells us that Earth's rest mass corresponds to an energy equivalent of approximately 5.4 times 10 to the 41st power joules, roughly equal to the total energy output of our Sun for about 1.5 million years. This enormous quantity of energy must go somewhere, transform into something else, or reveal fundamental gaps in our understanding of physical law. If we imagine this energy converting entirely into gravitational waves, the result would be a burst of space-time distortion, unlike anything ever observed. These waves would carry Earth's gravitational signature throughout the universe, eventually reaching every galaxy in the observable cosmos and beyond. The detection of such an event by hypothetical alien civilizations would provide them with a precise measurement of our planet's properties, creating a kind of cosmic tombstone that would persist for eternity. The philosophical implications of this permanent gravitational record touch on fundamental questions about the nature of existence and information. If Earth's characteristics remain forever encoded in the structure of space-time, in what sense can we say that our world has truly disappeared? The waves carry no matter, no chemical elements, no biological information, yet they preserve a perfect mathematical description of our planet's most fundamental physical properties. This gravitational memory effect suggests that the universe maintains an eternal record of everything that has ever existed within it. Every star that has ever shone, every planet that has ever formed, every black hole that has ever collapsed. All of these objects leave permanent traces in the fabric of space-time that continue propagating long after the matter and energy that created them have been redistributed throughout the cosmos. From this perspective, nothing in the universe is ever truly lost, merely transformed from one state to another in the grand conservation equations that govern reality. The atoms that currently make up our planet and everything on it will continue to exist, participating in new arrangements and configurations as the universe continues its evolution toward whatever strange and wonderful futures await. The timeline for this cosmic recycling extends far beyond the current age of the universe. Current cosmological models suggest that the era of star formation will continue for perhaps another trillion years, gradually slowing as the universe expands and the raw materials for stellar birth become increasingly dispersed. During this unimaginably long period, countless new planetary systems will form, and some fraction of these will likely develop conditions suitable for the emergence of life and consciousness. The heavy elements necessary for rocky planets and complex chemistry are continuously being manufactured in the nuclear furnaces of massive stars and distributed throughout space by supernova explosions. The carbon that forms the backbone of biological molecules, the oxygen that makes water possible, the silicon and iron that build planetary cores, all of these elements are being created and scattered by cosmic processes that will continue operating for eons. Given sufficient time and the right conditions, matter might once again organize itself into patterns capable of consciousness and wonder on worlds we cannot yet imagine, orbiting stars not yet born. The emergence of life and intelligence may be extraordinarily rare, but in a universe containing trillions upon trillions of planets, even the most improbable events become inevitable given enough opportunities. This cosmic perspective offers a kind of comfort in contemplating Earth's hypothetical disappearance. While our particular world and everything it contains would be lost, the universe would continue its patient exploration of complexity and consciousness across vast reaches of space and time. The atoms that currently comprise our bodies and our biosphere would eventually become incorporated into new stars and planets, carrying with them the potential for new forms of organization and awareness. We are made of star stuff, as Carl Sagan so beautifully expressed, and when our world eventually returns its borrowed atoms to the cosmic inventory, that star stuff will retain the potential for new arrangements, new possibilities, new experiments in what can emerge when matter and energy dance together according to the elegant laws of physics. The mathematical relationships that govern orbital mechanics, stellar evolution, and galactic dynamics would continue operating with the same precision they have maintained for nearly 14 billion years. These laws are indifferent to the particular arrangements of matter they describe, yet within their framework, the universe continuously creates new opportunities for complexity, beauty, and consciousness to emerge from fundamental particles and forces. As we approach the gentle conclusion of our cosmic journey, we find ourselves confronting one of the most profound paradoxes of existence. We are simultaneously insignificant specks in an unimaginably vast cosmos and the most complex known arrangements of matter and energy in the observable universe. We are temporary patterns that will eventually dissolve back into the cosmic background, yet we represent the universe's most remarkable achievement in organization and awareness. This dual nature of cosmic insignificance and absolute preciousness lies at the heart of what makes Earth's hypothetical disappearance so poignant to contemplate. From the perspective of galactic evolution or universal expansion, our world represents less than a rounding error in the cosmos's grand calculations. The Milky Way contains hundreds of billions of stars, and current estimates suggest there may be over 2 trillion galaxies in the observable universe alone. Yet, from the perspective of consciousness and meaning, Earth represents everything we have ever known or can hope to know about the nature of existence. Our entire understanding of physics, chemistry, biology, and consciousness derives from observations and experiments conducted on this single world, orbiting an ordinary yellow star in an unremarkable region of a typical spiral galaxy. The probability that all the factors necessary for complex life would align as they have on Earth appears vanishingly small. Current research suggests that potentially habitable planets may be extraordinarily rare, occurring around perhaps fewer than 1 star in a billion. The precise size needed to retain an atmosphere without becoming a gas giant, the right distance from the star to maintain liquid water, the presence of a large moon to stabilize axial tilt, the geological activity needed to maintain chemical balance, the magnetic field required to protect the atmosphere. All of these factors had to converge with remarkable precision. If these estimates are correct, then Earth may represent one of the universe's most precious achievements, a cosmic treasure whose rarity approaches the unique. The nearest world with similar conditions for life might lie hundreds or thousands of light years away, making our planet an almost unimaginably valuable repository of biological and cultural richness. The contemplation of this rarity imbues every moment of existence with profound significance. We are not just observers of the universe, but participants in its grandest experiment, temporary custodians of consciousness in a cosmos that may be largely devoid of awareness. Every sunset we witness, every piece of music that moves us, every scientific discovery that expands our understanding, every act of love and creativity, all of these experiences represent the universe becoming aware of its own beauty and mystery through the medium of conscious minds. The responsibility that comes with this awareness extends far beyond our own species to encompass the entire community of life that shares our planet. Every organism that has ever lived on Earth represents a unique solution to the challenges of existence, a particular approach to the fundamental problems of survival and reproduction that emerge through billions of years of evolutionary experimentation. The genetic diversity preserved in Earth's biosphere embodies information about biochemical processes that has been refined and tested across geological time. The complex ecosystems that link species together in webs of mutual dependence demonstrate principles of organization and cooperation that transcend biology to reveal fundamental truths about how complexity emerges from simple interactions. The disappearance of this biological library would represent a loss that transcends mere extinction to touch the very foundations of what is possible in a universe governed by physical law. Each species that vanished would take with it unique insights into the art of living, particular strategies for transforming matter and energy into self-sustaining patterns of organization and growth. Human consciousness adds another dimension to this cosmic significance, representing the point at which the universe develops the capacity for abstract thought, mathematical reasoning, artistic expression, and ethical reflection. Through human minds, the cosmos has learned to investigate its own structure through scientific inquiry, to create beauty through art and music, and to grapple with questions of meaning and purpose that arise naturally from conscious awareness. The languages we speak, the stories we tell, the equations we derive to describe natural phenomena, the paintings and symphonies we create to capture aspects of experience that cannot be reduced to pure physics. All of these cultural achievements represent the universe learning to know and express itself through the medium of conscious intelligence. The loss of this cultural richness would impoverish the cosmos in ways that extend far beyond the elimination of any particular species. Human civilization represents the accumulation of thousands of years of learning, creativity, and moral development, a collective achievement that builds upon the contributions of countless generations who struggled to understand their place in the cosmic order. The libraries that preserve our knowledge, the museums that house our artistic treasures, the scientific institutions that continue pushing the boundaries of human understanding, the philosophical traditions that grapple with ultimate questions about the nature of reality and consciousness. All of these cultural institutions represent humanity's attempt to create meaning and beauty from the raw materials of existence. Yet as we contemplate the magnitude of what would be lost if Earth disappeared, we must also acknowledge the profound humility that comes from understanding our true place in the cosmic hierarchy. Our planet orbits an ordinary star in the outer reaches of a typical spiral galaxy, one of hundreds of billions of galaxies in the observable universe. The total amount of matter and energy that comprises our world represents an infinitesimally small fraction of the cosmic inventory. The universe operated for over 9 billion years before our solar system formed, creating and destroying countless stars and planetary systems in an ongoing process of cosmic evolution that operates on scales far beyond human experience. The elements that make up our bodies were forged in the nuclear furnaces of ancient stars that lived and died billions of years ago, their ashes eventually becoming incorporated into the molecular clouds that gave birth to our Sun and its family of worlds. This cosmic recycling process ensures that our atoms are not permanent residents of Earth, but rather temporary visitors on a journey that began with the Big Bang and will continue long after our current arrangements have dissolved back into the cosmic background. We are patterns of organization that emerge from the interplay of matter and energy according to natural law, and we will eventually return to the cosmic inventory of materials available for future experiments in complexity and consciousness. The timescales involved in cosmic evolution dwarf human history and even the entire span of life on Earth. Our species has existed for only about 300,000 years, a brief moment compared to Earth's 4.5 billion year history. Complex life has flourished on our planet for roughly 600 million years, while simple organisms have been present for over 3.5 billion years. Yet even these vast biological timescales represent only a fraction of the universe's total age, and an even smaller fraction of its expected future evolution. Current cosmological models suggest that star formation will continue for perhaps another trillion years, gradually slowing as the universe expands and the raw materials for stellar birth become increasingly dispersed. During this unimaginably long period, countless new opportunities will arise for matter to organize itself into complex patterns capable of consciousness and creativity. If we could somehow observe the universe across these cosmic timescales, Earth's entire history might appear as nothing more than a brief flickering in the grand tapestry of cosmic evolution. Yet for us, in this particular moment of space and time, our planet represents the only known location where matter has achieved self-awareness and developed the capacity to contemplate the very processes that gave it birth. This paradox between cosmic insignificance and absolute importance defines the human condition and perhaps the condition of consciousness itself, wherever it may arise in the universe. We are simultaneously products of cosmic forces that operate on scales beyond imagination, and the only known observers capable of appreciating the beauty and mystery of those very forces. The contemplation of Earth's hypothetical disappearance thus becomes more than an exercise in astrophysics and orbital mechanics. It becomes a meditation on the nature of consciousness itself, on the extraordinary improbability that matter should organize itself in ways that allow it to wonder about its own existence, and on the profound responsibility that comes with being the cosmos's only known observers. In the gentle darkness of space, surrounded by the ancient light of distant stars, our small blue world continues its patient orbit around an ordinary yellow sun. The same gravitational forces that hold us in our path around our star also bind the atoms in our bodies, the molecules in our cells, the thoughts in our minds. We are not separate from the universe, but rather its most complex known expression, the way 14 billion years of cosmic evolution has learned to observe and appreciate its own magnificent structure. The aurora that dance above our polar regions are created by the same magnetic fields that protect our atmosphere from the solar wind. The tides that rise and fall in our oceans are driven by the same gravitational forces that hold the moon in its orbit around our world. The nuclear fusion that powers our sun operates according to the same physical principles that govern the formation of heavy elements in our bodies, and the energy metabolism that sustains all terrestrial life. We are woven into the fabric of cosmic existence at every level, from the quantum mechanical processes that enable consciousness to the galactic dynamics that shape our journey through space and time. Our thoughts and dreams emerge from neural networks that operate according to the same electrochemical principles that govern the behavior of matter throughout the universe. The capacity for love, wonder, creativity, and transcendent awareness that characterizes human consciousness represents perhaps the most remarkable development in the entire history of cosmic evolution. Through conscious minds, the universe has developed the ability to appreciate beauty, to ask questions about its own nature, and to create meaning from the raw materials of space, time, matter, and energy. This awakening of the cosmos to its own existence may be the most significant event in the nearly 14 billion years since the Big Bang. It represents matter becoming aware of the principles that govern its behavior, energy developing the capacity to contemplate its own transformations, and space and time learning to observe their own curvature and flow. As we drift towards sleep in the cosmic embrace of our small world, we can take comfort in knowing that we are part of something infinitely vast and beautiful, something that has been unfolding for eons and will continue long after our brief moment in the cosmic story has passed. We are the universe becoming conscious of itself, temporary arrangements of star stuff that have developed the capacity to wonder at their own stellar origins. The same nuclear processes that forge heavy elements in the cores of distant stars also power the biochemical reactions that sustain life on Earth. The gravitational waves that ripple through space-time carry information about cosmic events across billions of light years, connecting us to the most distant reaches of the observable universe through the fundamental structure of reality itself. In this moment of quiet contemplation, surrounded by the infinite darkness punctuated by the ancient light of countless suns, we can appreciate our extraordinary good fortune at existing during this brief golden age of cosmic complexity. We live in an era when the universe has cooled enough to allow the formation of complex structures, but has not yet expanded to the point where such structures become impossible to maintain. The window of opportunity for consciousness in the cosmos may be narrow, occurring only during a tiny fraction of cosmic time, when conditions happen to be suitable for the organization of matter and energy into increasingly sophisticated patterns. We are privileged to exist during this remarkable epoch, when the universe has achieved the capacity for self-awareness through the emergence of conscious minds capable of contemplating their own place in the cosmic order. The stars that shine in the darkness above us burn with the same nuclear fire that powers the chemical reactions in our cells. The atoms that form our bodies were assembled in stellar furnaces and scattered across space by supernovae explosions that illuminated distant galaxies billions of years ago. We are quite literally made of star stuff, but we are star stuff that has become aware of its stellar origins and capable of reaching toward an understanding of the cosmic processes that shaped us. As we settle into the peaceful embrace of sleep, we can rest in the knowledge that we are participants in the universe's grandest experiment, temporary but essential expressions of the cosmos learning to know and love itself through the miracle of consciousness. We are living proof that the universe contains not just matter and energy and the forces that govern their interaction, but also the potential for beauty, meaning, love, and transcendent awareness of the profound mystery of existence. In this cosmic lullaby, we find our place not as isolated beings struggling against an indifferent universe, but as integral notes in the greatest symphony ever composed, conscious expressions of the cosmos awakening to its own infinite beauty and mystery. Sleep now, knowing that you are part of this eternal dance, this magnificent unfolding, this grand experiment in what becomes possible when matter and energy learn to contemplate their own existence through the gentle miracle of consciousness, drifting peacefully through the star-filled darkness of space and time. As we continue our gentle drift through this cosmic meditation, let us turn our attention to the profound silence that would settle over the electromagnetic spectrum in the wake of Earth's disappearance. The radio waves that currently stream outward from our planet, carrying television broadcasts, cellular communications, and the constant chatter of human civilization, would cease their transmission instantly. These electromagnetic signals, traveling at the speed of light, represent humanity's inadvertent announcement of our presence to the cosmos, an expanding sphere of radio noise that currently extends roughly 80 light-years from Earth. In the profound quiet that would follow our planet's vanishing, this expanding bubble of human-generated signals would continue its journey outward through space, carrying with it the last evidence of our technological civilization. The earliest television broadcasts from the 1940s have already travelled nearly 80 light-years from their point of origin, potentially reaching star systems like HD 164595 in the constellation Hercules. These ancient signals, now faint whispers in the cosmic background, preserve fragments of human culture in electromagnetic form, frozen moments of our civilization propagating eternally through the void. The radio telescopes that currently scan the heavens for signs of extraterrestrial intelligence would fall silent, their great dish antennas no longer turning to track distant pulsars or search for patterns in the cosmic microwave background radiation. The Very Large Array in New Mexico, with its 27 radio dishes spread across the high desert, would lose its ability to function as a coherent instrument, each antenna becoming an isolated monument to humanity's quest to understand the cosmos through electromagnetic observation. The Arecibo message, that powerful radio transmission beamed toward the globular cluster Messier 13 in 1974, would continue its journey through interstellar space, carrying with it a mathematical description of human knowledge and our solar system's structure. This deliberate attempt at interstellar communication will not reach its destination for approximately 25,000 years, long after the gravitational waves from Earth's disappearance have swept through the same region of space. The space-based observatories that currently monitor the universe across the electromagnetic spectrum would find themselves in altered orbits following the disappearance of their home planet. The Hubble Space Telescope, orbiting Earth at an altitude of approximately 550 kilometers, would suddenly find itself in a heliocentric orbit rather than circling our vanished world. Its solar panels would continue to power its instruments, and its gyroscopes would maintain pointing stability. But there would be no ground control to command its observations or receive the magnificent images it captures of distant galaxies and nebulae. The infrared heat signature that Earth presents to space would vanish instantly, eliminating one of the ways our planet could potentially be detected by hypothetical alien civilizations. Current estimates suggest that an advanced alien telescope might be able to detect Earth's thermal emission against the background glow of our Sun, particularly during planetary transits when our world passes between its star and distant observers. This detection method, known as transit photometry, has already revealed thousands of exoplanets orbiting other stars and represents one of the primary techniques used in the search for potentially habitable worlds. The atmospheric composition of Earth, with its unusual abundance of oxygen and water vapor, creates a unique spectroscopic signature that astronomers consider a potential biosignature when detected around other worlds. The simultaneous presence of oxygen and methane in our atmosphere represents a chemical disequilibrium that would be difficult to maintain without biological processes continuously replenishing these reactive gases. The disappearance of this atmospheric signature would eliminate one of the most compelling pieces of evidence for life that our planet broadcasts to the cosmos. And so we reach the gentle end of our cosmic journey, having followed the ripples of Earth's hypothetical disappearance through space and time. From the moon's first moment of solitary flight to the last whisper of gravitational waves carrying our planet's memory to distant galaxies, we have witnessed how the universe would respond with mathematical precision, how orbital mechanics would adjust with quiet grace, and how the grand cosmic dance would continue largely unchanged by the absence of one small blue world. The moon would find its new path around the sun, the planets would maintain their ancient rhythms, and the stars would burn on in their patient nuclear fires, indifferent to our vanishing. Gravitational waves would propagate outward through space-time itself, encoding Earth's existence into the very fabric of reality, ensuring that even in absence, our world would achieve a kind of eternal remembrance written in the geometry of the cosmos. Yet in contemplating this vast indifference, we discover something profound about our own extraordinary fortune. Here, In this brief moment of cosmic time, matter has organized itself on our small world into patterns complex enough to ask these very questions, to wonder at their own existence, to find beauty in the mathematical laws that govern reality itself. We are the universe awakening to its own mystery, temporary arrangements of star stuff that have somehow learned to contemplate the stars from which they came. Earth may be insignificant in the grand calculations of cosmic evolution, but it is also irreplaceably precious as the only known stage where consciousness has emerged to appreciate the sublime dance of matter and energy across space and time. In the end, the universe's greatest achievement may not be the formation of galaxies or the birth of stars, but the emergence of minds capable of wondering at it all, of finding meaning in the mathematics, and of transforming the cold equations of physics into sources of beauty, love, and transcendent awareness of the infinite mystery that surrounds us all.